Welcome, everyone, and thank you for joining us today. Whether you're new to Jump or you're an experienced user, we're excited to have you here in today's webinar. Today's session is really about taking you on a journey beyond spreadsheet analytics, all the way from modeling to deep learning. And we'll explore how the integration of particularly image and text data into your analysis workflow can transform the way you work and how you can get to solutions fast, which is probably one of the most important tasks in your industries. My name is Florian Vogt, and I am your host for today. And the greater attention, of course, goes to my guests. It's my pleasure to now welcome David Barnett from Syngenta and Russ Wolfinger from Jump. Welcome both.
Thank you, Florian.
It's really great to have you here, and everybody's looking forward to hear what you have to share. And so we'll see you in a few minutes again. Yep. Nowadays, we know that data is abundant but often underutilized, and researchers and engineers are using AI more frequently for everything from drug discovery, material development, all the way to process optimization and quality control tasks. But there are common challenges remaining. For example, managing complex data sets or integrating different multiple data sources, extracting quick insights, and perhaps most critically, extracting the meaningful knowledge quickly and accurately. So despite the potential of AI, some of these challenges can sometimes feel very overwhelming. And another example would be setting up and training deep learning models or handling these types of data, unstructured image and text, that often requires some specialized coding skills and extensive resources. And even with the help of open source tools or consultants, the learning curve can be quite steep, and the time and money investment can be significant. And this is where Jump comes in. The software is really helpful to bridge this gap, putting powerful tools directly in the hands of scientists and engineers without the need for advanced programming expertise. And today, we'll show you how Jump can streamline your workflow, simplify the process of modeling and deep learning, and help you uncover valuable insights. And you will see some great examples of that and how Jump is used to solve these complex tasks. And we'll soon start with those. Now, by the end of the session, our goal is for you to see how Jump can help you overcome the hurdles of integrating AI into your processes, and to feel confident that these tools are not just for data science experts, they're accessible, practical, and bringing value across all the steps of the entire analytic workflow, and they're ready to help you to take your work to the next level. So let's dive in. We would like to start by getting actually a little bit more information from you, the audience, so that we know a little bit better who we talk to. And the first thing we would like to learn from you is about your background. So if you could please answer the poll question, which will appear on your screen shortly. This helps us and our speakers to understand the possible focus of interest, even though you can ask your specific questions later as well. So first question, does your organization currently have any artificial intelligence or machine learning initiatives? Please answer with yes or no. And then feel free to type in free text for the second question. What software tools do you currently use for predictive modeling?
I can see that people are still voting, so let's keep it open for a couple of seconds. Okay, it seems like everybody who wanted to has voted, so I will end the poll and share the results. So it looks like a majority of the organizations have already some kind of AI or machine learning initiative in place.
Yeah. That's thank you, Nina. That's a little bit expected. There's a big drive at the moment. I mean, nobody could not hear about what is happening in the AI world with ChatGPT and alike being around. And similarly, in the industries, we hear a lot of initiatives. But it's interesting to see also that about a third, 28%, I think it was, have not yet started to have, let's say, more global organization-wide initiatives. So interesting, and maybe this webinar is able to inspire those to get you started on your journey today. So let's start now with a quick sneak peek into the actual case studies covered by our experts. And I would like to invite you, Russ, to give us a quick overview about the examples on the menu for today. But also if you could give us more of a broader view on what types of challenges that can be solved and why JUMP is such a powerful tool in this environment. Russ, please.
Thank you, Florian. Yes, it's such an exciting time that we're in right now. But I did want to make a key point right up front is that we're focusing today on more classical AI and ML methods, not the modern generative ones like with ChatGPT that you mentioned, although those are very exciting and fun to work with. Our current stance is that these classic methods are very powerful nowadays, and we're looking to effectively democratize them through JUMP and make them very easy for scientists and engineers to access. So that's our primary focus today was on classic methods, although we are also doing several things with generative type techniques that we'll perhaps talk about in a future webinar. For now, though, we've got 4 key examples today that we wanted to go through. This first one that you see shown here are images from David, who will be going into this one in depth from Syngenta. And these are chemical formulation images that he's collected. He's indicated they've actually taken hundreds of thousands of these pictures. But right out of the gate, I wanted to mention, this is a JUMP table. And JUMP tables are very handy for, in this case, say, managing a series of images on the same object as a row. And then the columns are different, different sets of pictures. And then within each table, we can also assign labels or attributes, characteristics. And so this is usually the central point when you're working in JUMP. You'll have a table like this open, and you'll want to assemble it. JUMP's also very easy. It's also very easy to import these images and do data wrangling, feature engineering, et cetera. But David will be telling us all about these as kind of our feature example today. Our second example is also image-based. It comes from a nice paper from 2020 on scatterometry. And I'll be giving you some more details about that a little bit later. But let me just scan through the pictures here. You can see they look somewhat blurry, but they are little cropped sections from a scatterometry experiment measured at different diameters. And the objective here is to look at the image and try to predict with machine learning what that diameter is. So certainly not easy to do by eye, but it turns out that the machine learning methods are quite good at it. And we'll see how that goes with that one. Now, our final 2 examples are from a text style modeling. And for that, we'll begin with a problem that we're actually working with right in our JUMP internally these days. I thought this would be interesting to cover and also show that we're kind of eating our own cooking, as it were. These are data from our JUMP community chat board, where it's a very active community, jump.community.com, where folks from all across the world will post messages. And what we like to do is automatically classify the messages into one or more different buckets. For example, does it have to do with statistical modeling, or maybe data access, data exploration, et cetera? And these categories are not mutually exclusive. So the goal here now would be to take the text message, which you can also conveniently load into a cell of a JUMP table, and parse it with a machine learning model like BERT or whatever, and then predict the category just based on the text in the message. So a nice little machine learning text style problem using modern language models that we'll look at. And then finally, our final example is one that to me is really interesting and powerful, where we will take a chemical molecule and look at its SMILES string. And you can see several of those shown here. And the idea now is to just by looking at this string only, can we predict a numerical property like an activity? To me, this is something that humans, I don't think, are, unless it's a very extremely experienced person, this is something that's just kind of beyond what we can do. But it turns out these machine learning models are very good at predicting something like this. So that's a sneak preview, Florian, and we're going to dive into each one of them in more depth in a little while.
Great, thank you, Russ. Sounds very exciting, and it resonates well with what our user base is also discussing and asking for. So everybody is probably very much looking forward to this. And for those in the live audience, you will maybe have already noted, but you have the unique chance to ask questions to David and Russ live, and they will answer them in the Q&A, which we'll have at the end of today's webinar. So please submit all your questions to them via the Q&A section in the Zoom window that you have. Now, the projections of generative versus traditional AI predict, of course, a high potential for both. Yet, Russ has just mentioned it, the portion of generative AI in industrial applications will likely be a much smaller fraction in the near future. And this is partially due to the nature of the tasks that scientists and engineers typically solve, compared to, for example, departments like sales, marketing, and other departments where creative output is desired without really the deep need to understand how it was generated. But in science and engineering, you're typically more interested in a profound understanding of the decision-making process. So there's a bit of a difference. And there's also limitations. And one of the limitations in industrial application oftentimes comes from rather small data sets. Examples from product development could be that creation of only a single observation, a single, let's say, a sample product, meaning a single data point, actually can be very costly and time consuming. And this then contradicts with the nature of AI, where you would typically want to have rather large data sets to train these algorithms. And then another limitation, we briefly spoke about it in the beginning, is the availability of high quality data sets to train these algorithms, which is often not a given. Data sets can be complex, they can be in distributed locations like lab notebooks, analyzers, raw material, information systems, manufacturing systems, and so on. And this basically raises the demand to have a versatile tool in between, which allows you to perform all the steps from the raw data, maybe in different distributed sources, to prepare, explore, and then all the way to machine learning and artificial intelligence applications. And we'll soon hear more. Just again, want to bring up Russ briefly, because Russ has a long history and strong experience in machine learning and AI. And I would like him to share with all of you the benefits that JMP brings into any of his machine learning or AI projects. Russ, please.
Yeah, thank you, Florian. I'm really excited these days. As we mentioned, we're in this period of perhaps one of the most explosive surges of analytical productivity in human history. And just every day, new things are coming online. You may have seen this week, Nobel Prizes in both chemistry and physics were awarded to machine learning people. So very surprising in some respects, but just showing just how important and vital this area is now. And certainly in JMP, we don't do everything, but we do see ourselves potentially playing a very valuable role in kind of providing easy, quick access to these methods, especially the more classic ones, without having to sit down. Typically, for modern things, you'd have to sit down and write Python code as the usual way in some kind of Python notebook. And even experienced machine learners, this can be a time-consuming task, not only time, but mental energy, of which we all only have a limited amount each day. So we see JMP playing kind of a nice complementary role to coding, often maybe as a first look tool. So you've got a set of images. They're very easy to load into a JMP table, like I showed. You can quickly fit some convolutional neural nets, get an idea of the nature of the problem, and then maybe move into Python for more serious coding or deployment. And we see this kind of role being very useful. We actually have customers though who are using JMP already, going end to end with these kind of problems now. And so we're very excited with the ability now to be able to do predictive modeling on images and unstructured text. And then of course, JMP's long-standing strength is with tabular data, which we won't be talking at all about today, but I did want to mention that too. These methods are often really good for traditional spreadsheet style numeric features, and you can combine everything. So a very exciting time, all kinds of interesting problems and applications across every industry that we're aware of, Floria.
Yeah, thank you. Yeah, thank you for your point of view as a long-time practitioner. And yeah, well, I guess that just makes people more excited to see what it actually looks like. And I acknowledge that there is probably a few people that don't know JMP yet. And while our goal is, of course, to demonstrate these real-world case studies of AI in these science and engineering tasks that Russ has already introduced, it is not only about the algorithm, it's about the entire analytic workflow, from the raw data all the way to the insights, from the spreadsheet kind of data all the way to machine learning and AI. And yeah, for those unfamiliar with what JMP looks like, I will give you now just a brief flavor of some of these functionalities that Russ has just mentioned before we go into the examples of AI. So you should be able to see my screen now, and this is just a screenshot from a book I recently read in, and this is maybe just a very general example of a typical machine learning project checklist. But the thing that it points out really clearly, and that probably is visible in any machine learning project, is that the actual modeling part is only 1 or 2 steps, and the rest is all about getting the data, understanding the data, assuring that the data is of high quality, feature engineering, feature selection, building out candidate models, and then also when you have good models, how can you visualize these models? And really don't want to take up too much time here, but it's said for those that have never seen JMP, maybe just a quick flavor. So this is an example that you can find in industrial processes a lot. It's a continuous process data log. So we have a timestamp, and we have several process parameters and a parameter of interest, which in this case is impurity. And for the first task, getting a good understanding, we might want to choose the platform called Graph Builder, which is JMP's interactive way to build out graphs. So, for example, we might be interested in what does the trend of impurity over the time look like. So very easy, drag and drop. You can build out these graphs, and maybe even better if we add some coloring here, we can instantly see what is the problem that we're trying to understand, what is maybe a good solution for this type of problem or scenario. And then for the next parts of the process we just shared, very often you want to get a good understanding of the data in terms of the quality, and that might include stuff like transformations. And transformations and the like is very easy in JMP as well. For example, if we need to transform a variable, we can simply do that by right-clicking, searching for the transform that we would want to do, and then select it, and there it is. The transform variable is right there. We immediately see the new distribution. And there's much more to do, and really helpful is that JMP is also very nice and easy. With just a few additional clicks, we can automate all of these steps that are of repetitive nature, which then takes the burden of lengthy data preparation workflows. So by clicking that, you can see that we can easily extract information from a single column, or we can do some transformations to columns, and we can reproduce that in a nice and easy way. A few more things to maybe show if you want to get a good understanding of the situation. We're also interested in looking at the process variables. And here again, Graph Builder can be very powerful. We can select different parameters that we need to investigate in a view, and we can easily spot problems. And due to the interactivity of the software and all the graphs and platforms, we can also very nicely dive into the data to see and maybe have discussions with the people from production in this case as to why is this happening, so that we get really a good understanding of the data before we go into a scenario with machine learning applications. Now, there's more to this. For example, if we want to do data quality checks, we have platforms that screen automatically for outliers, also missing data. And the nice thing here again is it's interactive, so we can select those affected, and in the data table we can then scan through and check these. Are they valuable to be in there, or are they maybe due to exclude? So very quick and easy to get to a data set that's really ready for analysis. And then again, for tasks of understanding, or let's say creating features, we can of course use these graphs, and we can use transformations to create additional variables. But what's also quite nice is that we can use interactive ways to actually create labels or new variables. And one example that I find very powerful is that we can highlight those areas that look suspicious, for example, or that look beneficial even. We can just by right-clicking on it, create a label column. Let's say this is Unit 26 flow problem. And there we have it. We now have a new column in our data set that now has a label where we have selected these observations at hand. And then ultimately for the later parts where we want to look into variable selections, there's different methods that can be screening methods that build on Bootstrap forest algorithms to select the most impactful predictors. And if you want to build up candidate models, there's something called model screening, which is a very powerful utility that helps to find and compare those algorithms that are performing well in a given data set. And we can then use the prediction profiler to get a good understanding about how these models are predicting our given data set with these nice and interactive visualizations of a model. Yeah, so this is a quick overview, and I hope this has given a good flavor of how JMP looks like. And you can see It covers you from preparing the data at the very beginning all the way to selecting variables that are maybe important that are to be included, and that you should be definitely putting in your algorithms for training. Now, in a second, I will let David, our guest here, steal my screen. But before I do that, I just want to give you a short reminder. So if you have any questions, A, about the topics discussed by David and Russ, please submit them in the Q&A tab. And B, if you would like to get these functionalities on your computer, then you can download the add-in for Jump Pro from community.jump.com if you already have Jump Pro, or you can contact us via the contact form on our website, jump.com. And now I will hold my breath and let David take over my screen to share his example. David, please.
Okay, thank you, Florian. Hopefully you can see my screen now. Please let me know if you can't.
Works perfect.
Excellent. So at Syngenta Jetstil in the UK, we have a robotic system which takes thousands of pictures potentially each day. And part of the data analysis in the past, it used to be, how do we look at these images? And we've had some software which gives us a numerical output, and we can kind of handle that. We make some assumptions from it. So when I saw Jump 18 had this torch feature, this Python torch, I was really quite excited. So I immediately downloaded it and started to play with it. I mean, there's a few caveats around this. I am nowhere near a machine learning expert. I know very little about how this actual software works. Jump, I'm quite proficient in, so I'm quite good at that. So you mentioned high quality images. So we have that. We have very high quality image, and the lighting behind that is very consistent between all of these samples. That's one of the things I would say, that if you're analyzing an image, it does need to be consistently lit. If you just take a point and shoot camera, maybe off your phone, then the type of analysis you can do will be quite limited. So that's one thing I would, as a kind of lead into this analysis, I would say that the taking of the image is key. It's probably more important than the analysis. I'm not sure if Russ would agree with that, but anyway. So the analysis I've done is to actually go through a few thousand, so about 5,500 images, and actually designate them as a color. So in this column here, and also a rough visual assessment of what I think they look like. Again, it's very subjective, the analysis, and apologies, but these images are quite small. So whether they're homogeneous, whether there's some cream, and in the agrochemical world, there's things float, a bit like full fat milk, that you have this cream up the top. And we have samples which are the neat formulation, which tend to be yellow. And we have either cloudy yellow, which this one is, or we have normal yellow, so clear yellow. And I started to play with this, and you get quite excited with it. And the analysis I run through quite a few times. And again, hopefully you can see my Torch deep learning screen. And so you can run through various scenarios on here, and you have many different image models. Generally, I think this is how it works, that the quicker analysis is at the top, and the ones which take a very long time down the bottom. So I'm not going to run through any of this actual analysis because it does take quite a while to do. But I have a few examples here where you can see where I've varied different things. So analyzing through the visual assessment, so it's whether it's homogeneous, whether it's cream in sediment, and the color of it's a white, yellow, essentially, that's it. The advanced options box here gives you many different things that you can alter through it. I've found generally the default, which is what it's got set here, is good enough. It's good enough for the first look-see, but you can change through different, as I've got here, different image models, different epochs, different learning rates, layer sizes. There's many, many different things that you can do. Again, I'm no expert, so I just tend to stick to the default. And the training models that you have produce plots like this. So it gives you a visual assessment of how good your model is going to be and how good your training set actually is. And again, is lower the better from my simplistic view. So this blue one, model 15, is not as good as these two here, so 12 or 13. And there are many different plots that you get out. My first go-to thing is the confusion matrices, and it tells you roughly how, well, it does tell you how many agree the predicted against the actual. And again, it's my assessment, so it's very subjective. And I'm dare say I've got some of this wrong, so I'd always review this. I'd look at the model. What is it predicted? Is a model better than what I've actually said it is? And if it is, then I rerun it based on the my wrong assessments. As you can see, it is actually, so looking at this effectively an R-squared value, we're getting very good assessment on most things. So about 95% it predicts a cream, about 94 if it's homogeneous or not. Sediment it's not quite as good at, but if it's a neat formulation, so that's effectively if it's yellow or not, it's good at. And if it's just plain water, so it's 11 samples which is just plain water, which I did that, and it perfect prediction on that. And there's more that you can actually look at from here. Again, on the color, it's not quite as good. Sorry, it is slightly better productivity, but I guess a color and RGB type of value is simpler than whether a sample is sedimenting or not. And so from this, I can then look at the data. I can assess whether the prediction is correct or not, and then reiterate it and go through it again, and then improve it. So the idea is that for these 5,500 images, you can then expand it potentially to the hundreds, thousands of samples that we actually have, and keep on correcting it as we go through each data set that we have, because these are all very discrete data sets, and we could hopefully get a model which will conquer everything. I think that's doubtful, but we can give it a go once I've got everything there. So again, just reiterating that it is very simple to do. I would recommend getting a high spec laptop or desktop to run this, because it is very memory intensive. But the outcome is very simple to understand, and if I can understand it, it's very simple. And so therefore, I'd recommend that most people give it a go. Again, consistent images is kind of the key input that you must have from this. And yeah, it's been very useful to use in a real life situation as well. So with that, I'll pass over to Russ.
All right, thank you, David. I was just, I've been furiously typing answers in the chat. Thanks everybody for posting those. We've got a lot of action there and good to see it. A lot of great questions. So let's go through. I've got, and thank you, David. That was very informative. So excited to see that application. And it's exactly the kind of thing we were hoping would happen with the add-in. And we're just starting to see more and more folks do things similarly. But let's take a look at a couple other examples to kind of give a bigger idea of what's possible here. And honestly, I'm literally finding hundreds, I guess thousands of potential examples now. I did want to mention right out of the gate that the add-in, the Torch deep learning add-in, which is what we're using here, comes with a Torch storybook file that currently includes 47 examples of different kinds, most of which are text and image, but there are some tabular ones as well. I know one of the questions was already asking about, do you have any examples that we can work through? And each one of these is kind of a complete worked example that includes a publicly available data set, a JMP journal, a JMP table and journal with results, as well as the backstory around each. And in fact, two of the two text examples that I'll show in a moment both come from this. But before that, I have a brand new example today. It's the first time that I've shown it because I was just working through it and was really excited to share with you today. This came from a paper published back in 2020 by Dimitro Kolanov and colleagues from the University of Delft in the Netherlands. This is an optics style problem dealing with scatterometry. And as I previewed earlier, we want to do nanoparticle classification with these scatterometry images. And I refer you to this paper for the details behind it. But kudos to them. They made the data as well as their code publicly available online. So we're just working with it. And you can see here the basic idea was they hit these particles with a laser and then grab the pictures. And then they go along and make little crops of sections. And then the idea is for each little crop that's made, can we determine the diameter of the nanoparticle? And so in this case, there are 5 separate categories that are predictable: 40, 50, 60, 80. And then they also gathered some background images for a total of 1,300 in this case. And these were easy to load into a JMP table, as shown here, which
Russ,
and to do that. Sorry, go ahead,
Russ.
Florian. Am I sharing?
Yeah, I was not sure if it's just me, but I cannot see your screen at the moment.
Oh, sorry. Hang on 1 second. I think I forgot to share. How's that, Florian?
It's doing something. There we go. Yeah, it's the example you already introduced in the beginning. So yeah,
Thank you.
Keep going.
That's good. Thank you so much, Florian. Sorry about that.
No
let me
problem.
go back. I
Nothing
wanted
else.
to make sure I highlighted the paper, which is here in Applied Optics, Dimitro Kolanov and colleagues from University of Delft. And this is a great paper. And they, like I mentioned, they made the data nicely publicly available. Thank you so much for doing that. It really helps, I think, further research. Helps cases like this where we can look at it further and maybe gather some new insights. But as you can see here, all the details are here, including how they use this 4 or 5 nanometer laser to hit the particles and then capture these images and then make crops. And it's these little crops that we are now analyzing in JMP and classifying. The goal is basically to classify the image into 1 of 5 categories: either the diameter, which has 1 of 4 possible values, or also some negative images, the backgrounds, which is often very good to include. So back to the table. Let's see here. Here we've got it loaded in, and along with the label, this is our key column that we want to predict. And then the way to set it up with the add-in is really easy. Once you install, you need JMP Pro, you install the add-in, and then you'll get this Torch Deep Learning menu under the add-ins. And if you just launch the dialog, you really only need 3 columns. In this case, you take the picture as your X, which is like the input. The diameter is the Y, which in this case, we're doing image classification with 5 possible categories. And then we recommend doing some kind of k-fold cross-validation. In this case, I've set up some fold columns, in this case, a 5-fold, where it'll run the model 5 times. So you just need those 3 columns in your table, and then click OK. And you then come up with the second dialog that David was showing, where you can choose an image model. We've got a lot to choose from and more that you can download. as well as you get into it more, there are these advanced options for really going after it in terms of more advanced machine learning, including things like augmentation, controlling your batch size, etc. We won't go into that today. We do try to make the defaults fairly sensible, but for most problems, and since there's such a wide variety now of problems, this default LeanNet model often will not work that great. Some problems it works fantastic, other ones not so much. And note too, a key thing is that it does assume an image size of 28 by 28 pixels, which again, for some problems, that's fine. Other ones, it's that resolution is way too low, and it makes sense to increase that and use a more advanced model. So all the flexibilities here, we're trying to strike a good balance between ease of use, but still giving you a lot of power and flexibility. There's still a bit of a learning curve to get going, but we hope it's not too bad. We're trying to strike the right balance here. And again, for sake of time, we won't run this live. I think it takes a few minutes to train, which also depends on your hardware. And by the way, with regard to that, it's good to have a Windows machine with an NVIDIA GPU with decent performance, and you need to have the CUDA libraries installed, and then you can use GPU power. Or if you're on a Macintosh, you can use metal performance shading on one of the more modern M chips. I think M3 is the latest. The NVIDIA cards tend to perform a little faster, but we're in a hardware war now, where the chip makers are trying to leapfrog each other in terms of speed, which is great for us. So I'll just skip right to the results here for this one, where we've got, let's see, what I did was I just saved several model fits into a jump journal, which is a convenient mechanism for saving results. And you can see here, I fit a series, in this case, of 8 different models. And the dialog has a nice way to accumulate results to compare. And you can see I was able to, over kind of with a little bit of tuning, able to increase the initial validation accuracy from around 80% all the way up to 97 by using an efficient net B2 architecture. So these are the kinds of gains you can expect. And you can see here along the way, I did increase the image size up to 150 to get that. And these are all dependent on the problem. But again, we're trying to give you enough flexibility here to really tackle most any kind of image classification problem. All right, so that's that one. Let's switch now to our text example. And remember, we've got 2 of them. This first one is our discussion board from our JUMP community. And here again, we've got posts to the board that we collected over time. In this case, 13,000 of them. And then the goal was to classify the post into one of our main buckets in terms of the topic. So we want to look at the words in a comment and try to pick out the sentiment, in a sense, or the category that the person was talking about, which is very similar to like a sentiment style analysis as well. And this basic paradigm works for all kinds of unstructured text. We've got another customer using it now on patent data. We're doing things with scientific abstracts, etc. The setup tends to be the same. And here now, instead of image models, you're offered a set of text style models. So let's take a look at that real quickly here. And again, you'll need to set up this unstructured text column as your input. And then this is a case where we've got 16 different Ys that will predict simultaneously with one single model. You can do that. And then you'll see now the menu changes where you're now offered some various text style models, most of which, the ones we find most useful now tend to be variations on the so-called BERT, bidirectional transformer models that are very popular and have been worked out quite heavily now with natural language processing, language translation models, etc., and also form a key part of the really huge modern chat style models that have now exploded into the billions of parameters. These only have millions, which are still pretty big models. but nothing like the really big ones. So there's all these orders of magnitude now of size that we can get into. And then as far as results for this one, let's take a quick look. Here we've got, again, this is just from one run, but we were able across each of the categories to get accuracies often above 99%. Sometimes there's really nice keywords that just pretty much nail the post. Some of the other categories were a little more difficult, but overall, we're pretty happy so far with the performance of these models, and way better than trying to go through manually, which is very tedious. You do need a set of training examples originally, so you got to put in the hard work to label up front with these data. But then once you get a decent set, you can often bootstrap yourself up and use the models to help label everything else. And then finally, let's kind of come full circle around back to a chemical application. This is the so-called SMILES string input. And here again, I'm just really impressed with the potential of this. Just think about, I mean, all the possibilities here where we want to predict some property of a molecule. And sometimes these properties are expensive to measure. And so by just doing a training set, in this case, we've got around 1,700, 1,800 molecules. We can train a model to predict this activity and then apply the model to hundreds of thousands of other molecules, basically just right on the computer. And in this case, for this particular problem, we're looking at an IC50 activity characteristic. And the results, again, are pretty promising, where we can get, in this case, R squares often up above 90. And one other thing I wanted to mention here is we also have some chemistry specific models now that use graph neural networks. We can model the molecule itself, and we take advantage of the open source library RDKit to build features for that and fit the so-called ChemProp style model. And it will often do a little bit better than the generic BERT style models, but you can try both. And I've seen cases where they're both very competitive. So Florian, let me pass it back to you now. That's kind of a quick tour. We could there's all kinds of fun things to talk about here. I hope that gives a flavor of what's possible.
Yeah, no, that was great. And by the speed at which questions are coming in, we can see that this resonates very well with a lot of you in the audience. So thank you very much for sharing both your stories, Russ and David. And yeah, so it's very easy to tell that this is spot on relevant for many of you in the industry, and particularly the combination of the visual data discovery methods, easy data wrangling, and also then the bridge into these AI algorithms, which are very easily accessible, as you have seen in the interface, no code needed. Yeah. Impressive example from David that he showed, and how this has saved a lot of work, or maybe also even extended and helped being a little bit more certain about the decisions that he is making in his work. And then, of course, the broader applications that Russ has pointed out. Yeah, and all of that in that environment, which has been designed to meet the needs of scientists and engineers for more than 35 years now. So a great combination. And yeah, I'm sure this has sparked a lot of ideas. You can see from the questions also. And of course, the pressing interest, how you can get started for yourself right away. And yeah, really can only invite you to get in touch with your local support team. Go to our website, jump.com, and then fill in the contact form. And yeah, for now, I would like to bring David and Russ back in for a live Q&A. We have had a lot of questions here. And before we go into the questions, we would like to, again, ask a little bit more from you to get a better understanding. And we have another poll coming up with 2 more questions I'd like you to answer while we are getting ready to answer your questions that you're submitting. So first question is, about what kind of data that you're looking at. So what are you most interested in using these tools for? Is it image data? Is it text data? Or is it tabular data? And then again, a free text way to input answers on what are your biggest challenges in these encounters with AI and machine learning. I'll give you a minute to answer these.
Yeah, there are still answers coming in. Let's just give it a little bit. Thank you all for participating. And I will end the poll now.
Thank you, Nina, for taking
I'll
care.
share the results.
Interesting.
So that's a pretty even distribution, I would say, for the first question.
Yeah. Well, it's so if I just read the results, first question, what type of data you're looking at? That's 73%, and it 73% of you have selected image data. So that's obviously very important. And this is something, that I see from working with customers. There's so many images actually taken, visual inspections or gradings. So this is a very relevant topic, as for example, we have seen in David's example. A little text, 35% are interested in text, and a bit more than half have answered that tabular data is also relevant for them. So I think, it's a combination of all. Russ, maybe you have also some impression on a more global view. What's the most requested type?
Yeah, I saw one of the big survey places, Gartner or somebody, estimated that around 80% of enterprise data is so-called unstructured, which would be tabular plus, or sorry, text plus image. It's hard to say exactly how they came up with that, but seems somewhat plausible. And I know just like nowadays with phones and stuff, I mean, I think my daughters literally have tens of thousands, hundreds of thousands of pictures already on their phone. So it's just so easy nowadays to take pictures. I got to believe that those are just going to be expanding more and more as time goes along.
Yeah, definitely. Yeah. So we have a lot of questions and little time. We have been trying to answer as many questions. Russ is probably hot fingers from typing while others were speaking. Dave has also answered a few, but we have still a few left. They came in a little bit mixed Q&A and chat. So we have two questions here that we haven't answered yet. So one of them is about the deployment. How can these models be deployed in practice? Maybe David, do you have some information for us?
Yeah, so you can deploy the model. The way I personally would do it is to use JMP to actually develop the model, and as part of that JMP add-in, you can actually export it as a Python code, and you could then put that in as a Windows service. I dare say you could use JMP itself to actually run that, but I think if you want it repetitively done, maybe put it as a Windows service, but the Python code generated directly from JMP, you don't have to write any code.
Yeah. Russ, any additions?
Yeah, and it actually, the timing is beautiful because we've also JMP is just with JMP 18, we've had a very significant upgrade with our Python integration. So this meshes very well with that. All the models are saved as PyTorch serialized files to disk. And so you can hop right over into Python and set up PyTorch code to import those directly. And we already have customers who have built some production level models and got them in their workflow pipelines for deploying. So kind of a really nice setup.
Cool. Yeah. So that apparently is a very interesting topic, but we also had a lot of questions about the hardware. So people were wondering if they need to upgrade hardware. Do we have any recommendations to hardware? Maybe you can touch briefly on it. Probably easier to share a document where all of that is written down.
Yeah. Well, one good thing is if you've been looking for justification to get a faster computer from your boss or whatever, we got it. We got it for you. And so we definitely try to take advantage of NVIDIA on Windows. We're kind of in this weird scenario where, since Apple and NVIDIA don't get along so well, if you're on Windows, NVIDIA cards are the way to go. And thankfully, they're quite affordable because of the gaming world. And which is also why NVIDIA is doing so well as a company. They kind of got these dual business models now. But pretty much at any budget level, you can find a reasonably decent NVIDIA card that will often work quite well. And then on the Mac side, as I mentioned, you'd want to get the more modern M series chips, like I think M3 is the latest. And I know Intel and the other big manufacturers are going gangbusters now for speed. We're in a battle now to see who can be the fastest. We're like, bring it on. We've got the data,
which is good for us. Yeah. Yeah. So it's a good, yeah. And we have more resources on that. If you want to know more in detail, then get in touch with us. Yeah. There's a lot of other questions coming in, and one, let's say, a little bit of broader perspective is on, let's say, the entire framework. So there's questions on how can you get the picture data into JMP, and we have had an answer from Russ already. We have utilities that can do that. You can load a folder full of images with our multiple file import capability, so that does the job in an instance, no worry. But also on the back end and in the in-between, somebody's asked a very exciting question where we actually have an example created in the Torch book for you. And the question is about, can we use functional data or spectra also as images, so use something to predict an outcome. And I think this is a very powerful thing on top of what JMP offers, because we have these functionalities that do the data crunching preparation. We do have the AI backend with what we've seen today, but we also have all of the in-between. JMP can create analysis for functional data, so you can analyze spectral data, for example, as a question was. But you can also do stuff that Russ has pointed out. You can create images of your data, whether that's a sensor stream. You can create heat maps that display what's going on in your processes. But you can also create images of spectra and then use these for classification algorithms. So it's a really powerful package altogether. And yeah, really at the end of time, there's so many questions, we cannot answer them all. It was really great that you have come with such an enthusiasm in here, and so we'll make sure that we answer these questions offline that haven't been answered yet. Also take a look at the recording afterwards. For now, I would like to close the Q&A. Say a very big thank you to David and Russ. And yeah, if you don't have any particular questions at this moment, you can now sign up to receive email communications for further information. There's a poll window just appearing now. And yeah, while you're answering that, again, big thank you. It was very great to have you. Hope to see you soon again. It's definitely a very relevant topic. Thank you, Russ and David.
Yeah. Hey, Florian, one last thing I wanted to mention. Just this week, we've launched the JMP Marketplace, which is kind of a brand new repository for add-ins like the Torch add-in. So I wanted to encourage folks to keep an eye out for that. And already in the chat, there's a link to the community page, which has been our traditional way of sharing it, but we're kind of transitioning now to this new marketplace, which I'm very excited about. It's kind of an upgrade in terms of sharing. It's kind of like the JMP app store, if you want to view it like that. And Torch is in there. There's also a bunch of other really interesting ones. XGBoost, there's ones for students. So another one that does with RDKit. and other Bayesian optimization. Just a really, it's already going gangbusters, and just launched this week. So I think this might be the first time we're announcing it kind of in a public webinar. So encourage folks to check it out. I think you just search for Jump Marketplace. I think the URL is like
marketplace.jump.com.
yeah,
yes.
marketplace.jump.com. Check that out.
Yeah.
That's where the latest stuff will be.
Cool. Yeah. Thank you for that addition. Very exciting, all the stuff that we have to offer. I hope you have gotten a good impression of what is possible with these methods that have been shown by Russ and David, and also what value Jump brings into that entire framework of AI and machine learning. And if you would like to get more information on that, please contact your local Jump support team via the contact form on our website, jump.com. And for now, I would like to thank everybody for joining this webinar and all the questions that have been brought along, and wish you a great rest of the day. Thank you and goodbye.